So our next speakers are Daniel Koo and Bryan Robbins from FINRA. They are also the inventors of a framework which they call MSL, and they're going to tell us how MSL has helped them improve UI testing at FINRA.
Cool. All right, thanks for the introduction. Yeah, so my name is Daniel Koo. We're here to talk about a tool that we open sourced this year called MSL. It stands for Mock Service Layer. And we're very excited to come here and share about a tool, and hopefully all of you guys will find this interesting, and you guys will use this when you guys go back. I know we talked a lot about mocking and moving fast and hermetic testing, and I think our talk will definitely resonate with those topics, so we're very excited. All right, so what am I trying to say with this slide? I think these are some of the trends that we are seeing in the industry today, right? Things like Agile, faster time to market, continuous delivery, having high quality. All of these are great goals for software projects. And of course, these are goals that we had at FINRA too. But while trying to achieve these goals, we observed a few things. First, we were observing that devs were actually moving faster, delivering faster, but tests were sort of struggling, and they were becoming bottlenecks and moving slower. Definitely there are challenges while trying to achieve these goals. And FINRA had its own challenges too. So brief introduction on FINRA. FINRA stands for Financial Industry Regulatory Authority. We pretty much oversee and regulate the majority of the securities firm doing business in the US. We also monitor the market data, more than 6 billion trades per day, more than 30 billion transactions per day, and more than 10 terabytes of data is what we analyze on a day-to-day basis. Our mission is to protect investors like us and promote market integrity. The nature of our business and our mission brought these unique challenges to us. First, the visibility aspect. If we make a mistake and it happens in production, we could end up on the Wall Street Journal the next day. So we pay very close attention to the quality of our software. And as I mentioned before, the enormous amount of data that we ingest every day, and the type of analysis that we do and the workflows that gets into these analysis just makes our systems very complex in nature. And in turn, it makes our testing that more challenging. So this is when I started to think about, okay, I want to achieve those goals, move fast, deliver fast to our customers while not compromising quality. And that's how MSL was born. So I'm going to hand it over to Bryan. He's going to talk about how our automation approach has evolved throughout the years. I'm going to dive into more details on MSL.
Cool. So this is another theme that we've already heard a few times here at the conference. This is our rendition of it. It's basically to say that if you had come to us 2.5, 3 years ago within our company and said, how should I automate my tests? Our primary recommendation would have been Selenium WebDriver. Go and make functional browser full stack automation for every feature. And by the time you're done, you'll have great coverage and it's a great approach to testing, right? But as we start to move faster, those things are flaky. So I've got execution time on my y-axis. You could put flakiness there. You could put development effort there. You could put a lot of different variables there. And the more of these full stack UI tests, there's so many dependencies, it just becomes intractable. Again, that's a theme you've already heard. So about 1.5 years ago, one emphasis we started putting in place and swapping out. So we'll replace some of these end-to-end tests, the ones that are trying to test back-end features. We'll just use direct API tests for those. Now this depends on having devs that design things properly, but most of our current frameworks, right, they actually have MVC or something like that in place, right? So API testing isn't that big of a deal. MSL really comes in to the next level of this. So last year at GTAC, we heard about things like Karma and test runners for UI-specific code. And could we take the same approach to isolation, where we have been isolating the back end? Could we isolate the front end in the same way? So that's how we view this sort of evolution at our company. So how are we doing this with MSL? It's basically a tool for what we call client-side integration testing. That means to take your full client-side code, the JavaScript, the CSS, HTML, and whatnot, right? And to locally deploy this using a Node.js server. And this is going to let you, without having to build, even in some cases, to start doing some tests against your UI features, right? So obviously we're removing, excuse me, obviously we're removing a lot of dependencies when we do this, right? So the missile server has your app code, and it's basically going to use a test runner to open up a test. The test will have API calls back to the missile server, and we'll show plenty of examples of that later in the talk. So basically the idea is a client-server kind of model where the server is doing some mocking for you to aid you in setting up and executing tests. Demo time.
It's demo time. So we're going to do a live demo, because live demos are cool. And we're going to show this with the Wi-Fi off, just to prove that we are doing hermetic testing. All right. All right. So, so we got up and running. So to install missile server, it's pretty simple. It's up on npm. So all you need to do is globally install missile server. If I can type. Now I'm not going to run this because it's already installed. So it's already installed. All right. So now the code that we are interested in is right here. This has all of the front-end code. It's got the JavaScripts, the HTMLs, and CSS files that we're trying to test. All right, so I'm going to fire off the missile server, and we do it by this. Missile, and we give the port number. And there you go. Now you have the missile. Missile has launched from here. It's running on this directory on this port. So now let's open up the app. Localhost, sample app. And there you go. So it's simple as that. We have the app up and running. And what I'm going to do is I'm going to perform an interactive action which actually triggers a REST call, but it's going to fail because, well, we have no REST services actually up and running, right? So you can see here we get a 404, and there's nothing coming back. So I'm going to show you how we can mock this so we can actually test the front-end code. All right, so we're going to use Jasmine for running our tests. So we've got the Jasmine library here, and here is where we include our missile client library. So we've got the mock API browser. So this is the JavaScript that allows you to talk back to the missile server. We also have the app container driver JavaScript, which allows you to drive your interactive scenario. And of course, here is my Jasmine spec file. So now I'll show you the spec file. So we have two tests in here. And the first thing we do before running any of the tests, what we do is we call this function called open app that's part of our app container driver, which opens the app that's running on the missile server. So we make sure we reset and always have the app running in the same state. Next, going into the test. So what we're going to do is we're going to stage the mocks before we do our interactions. So we call this function setMockRespond, which basically tells the missile server to intercept all the URLs, all the requests that matches this URL, and respond with this JSON response. And you can give the status code 200. You can also add delay time, but in our case, we're not going to add any delays. And then what we're going to do is we're going to use, again, our app container driver to get the elements and perform some actions. And we've implemented this using jQuery because everything's running inside a browser, and we didn't want to use Selenium or anything like that to drive the test from outside. So what we do is we type and we click, and then we're going to validate that the dropdown that comes down when we do a type ahead is actually, it contains the items that we have mocked in the JSON response. And then we're going to click on the second item, and we're going to see that it actually selected the second item, and the type ahead is populated with that. The second test is going to test that the app fired off XHR correctly. So we do that by calling this function, setInterceptXHR, which again tells the missile server, go intercept everything, all HTTP requests that matches this URL. And then again, we do the interactions. And then we call this getInterceptedXHR method, which will retrieve back everything that's intercepted, and we're going to validate that the URL was correct and it was a get method. All right, so let's fire off the test. It's going to be very fast, so you guys have to watch carefully. All right, test done. 2 tests done, and you guys saw the drop down that came down, right? So that's what we have mocked. So now Bryan's going to talk about how you can use this in Karma using our plugin. And before I hand it off, I'm going to turn off the server because our plugin is actually going to start up the missile server by itself.
Great. So with the missile stuff that we've shown so far in hand, right, you're taking advantage of a framework like Jasmine. And what we would need to add to that is some kind of runner, something to launch the browser, something to do reporting. As it turns out, there's some pretty smart runners out there. We chose Karma, and we decided to implement a small plugin with Karma that will start up your missile server and kill it when it's finished, and those kind of things, and maybe some other integration points. So here's an example of how to hook it up. You know, our plugin is available on Karma's default repos, right? So you can just add missile as a framework. And when you go through your files, there's no need to include any files other than just your spec. So you saw in our Jasmine spec, we had to add all of our specific files there. You don't have to do that with the Karma plugin. And then there's a block for missile-specific configuration here. So this is saying, you know, we want to run missile on port 8002. This is going to be behind Karma's own port, which is usually something like 9876 or something like that. The Karma port needs to match the port in your test. The missile port is sort of hidden from all that. And the way we accomplish that is via Karma's proxy support. So we're going to route all requests on the root URL to the mocking server, right? So this is the way we hook this up. We can foresee maybe extending some of the features of this plugin to maybe set that proxy for you automatically or do something cool, but not quite there yet. So let's quickly just run this.
The browser's behind the window, but it worked.
Sure.
Try running it
One more time.
There you go.
There we go. So again, Karma's ran the same test, but with JUnit reporting and all the nice features that Karma gives you. You can also swap out other browsers and that sort of thing. So great. One last thing. So we're out on GitHub, as we mentioned. So we've got full docs there, as well as a user. Oh, you took off the Wi-Fi. Yes, our GitHub page is not a hermetic page.
This is not part of the testing. It's okay. It's all right.
Does that count? So yeah, we're out on GitHub. We have full docs of our all of our APIs there. So we've written not just a JavaScript client, but also Java and Node.js and Python and Ruby. Of course, you could use something like WireMock if you're totally Java all the time. But if you need something that maybe would switch back and forth and could leverage the same mocking ideas, we do have the different clients. And we need to give a shout out to the other half of our team back in DC. Jake and Chen have put a lot of work into this stuff for us. So that's the rest of our team. And with that, we're done.
Thanks.